Welcome to Cliff Problem Part C, the exciting sequel to Cliff Problem Parts A and B. We are talking about this problem right here, and this file is in the same folder as this video. We are going to be doing Part C, which is what is the velocity and position of the ball at exactly 1.1 seconds from its release. Now to do this, we are going to have to use the same problem as this, okay? Only we're going to use some of the things that are given to us and transfer them over to our another little horizontal vertical table here. So we do that, and it looks something like this. SUVAT, and this is horizontal and this is vertical. Now it says at 1.1 seconds, so that's what we know. We know 1.1 seconds, 1.1 seconds, right? And then this is, we're still on Earth, so this is negative 9.81 meters per second squared. This is still 0. And then we don't know how far over it is or how far down it is, okay? Because we're not talking about hitting the ground. We're just talking about 1.1 seconds for some reason, right? So this is, we do know that it's the same launch, so it's the same velocity here and the same velocity there. And all we need to do is fill out, and we also know that the initial is still 0. And we just have to fill out what this is, and what this is, okay, for the problem. Okay, so let's pause a moment here. And so here we are, it's being shot off to the side at 8.216 meters per second horizontally, and it's 1.1 seconds into the flight, and we want to know basically how high it is, how far over it is. We also want to know how fast it's moving to the side. We already know that. And we also want to know how fast it's moving down. Okay, and we're going to make this into a vector like this. So let's just start solving here. In the horizontal direction, we can figure out the initial velocity. It's always this. It's always s equals ut, right? So we can just say s equals 8.216 times 1.1, which equals, and there it is in the calculator. I'm getting that it's about 9.0376 meters over, and so that's our S. And then here we can solve for the displacement on this side, using S equals ut plus 1FAT squared. Yeah, we'll plug in the numbers. That looks like this. And there it is with the numbers plugged in, and when we plug that into the calculator, it looks like this. And there's our answer in the calculator, -5. So it means that we've gone down from the top 5.9305 meters, and then we can find the final velocity by just using v in the vertical direction. V equals u plus at, which is 0 plus -9.81 times 1.1, which looks like this on the calculator. I get -10.791. And now we're all ready to give the position of this thing. I know exactly where this thing is. Horizontally, it's over here, 9.0 meters over. And I know that the displacement down here is -5.9 meters down. Here is our vertical displacement, so from the top down 5.9 over 9.0 meters, right? We could, since we know the cliff is 21 meters tall, we could also figure out the height of it. It would just be 21 minus 5.9, right? Okay, and then we also know the velocity of this thing, right? It says give the velocity of the ball right? And the velocity, whenever they say velocity, they always mean that it should be an angle magnitude vector. So here's what it looks like. Right at this point right here, okay, it is going over 8.216 and down a bit faster, minus 10.791. Right? So we're talking about that vector right there. Looks like this. Okay? And then we can have a magnitude and an angle. Okay? The magnitude is the hypotenuse. So this speed here is the square root of 8.216 squared plus 10.791 squared, which looks like this. And there it is in the calculator, about 13.656. So we'd have to say, I guess, a speed of 14 meters per second. Right, and then we can find an angle. Let's find that angle right there. This is the opposite side. Here's the adjacent side. And so that angle is tan minus 1 of the opposite side, 10.79.